Hello guys, welcome to the YouTube channel, and today we'll be taking a look at how do you perform the transient response analysis in Hypermesh software. So, transient response analysis, first of all, a little bit about transient response analysis. Transient response analysis is used to calculate the response of a structure to time dependent loading. Means if your loading is subjected to timing, if it is a function of timing, the magnitude of which is changing with respect to time, then the transient response analysis can be performed. Now you cannot define time dependent loading in static analysis, and that is the reason you should be performing transient response analysis. So now that you have a basic understanding of what the transient response analysis is, let's get into how could you perform the transient response analysis. So if you want to learn how to generate a mesh like this, you can just move back to the previous video. I have already made a video. So let's get into our transient response analysis, and let's first of all define the material. Steel, isotropic, mat 1, steel. As type as isotropic, card image as mat 1, and then create edit. We'll be using the default value for Young's modulus, Poisson's ratio, and density rho. Now that we have defined material, let's define property. Property name as solid, type as 3D, and card image as p solid, material as steel that we have just defined, and create. Now let's assign our component the material cell properties that we have just defined. Now that we have defined the properties and material to our component, let's first constrain our component. So for that, load collector SPC, you can name it whatever you want. We'll change the color to black and then create. Now go back to analysis page and constraint, select constraint, and use faces here so that the software will detect each of the nodes on that face that we have just selected. Make sure all the degrees of freedom are checked and they don't have any magnitude, or else they have magnitude as 0. Load type must be SPC, not D area, and let's create. So now we have our object is constrained. Now let's define loading. Let's move back to load collector and define loading as, say, load. Create. Now from here, watch carefully. Let's go back to constraint and select nodes. Carefully select nodes. It has selected 17 nodes, the stream of nodes, and now in what direction you want to apply the force. So, yeah, we are using constraint to define loading. So, make sure all the degrees of freedom are unchecked, and the only degree of freedom should be checked in which we are applying the load. So we are applying the load in x direction. So what is the degree of freedom for x direction? It is degree of freedom 1 for the translation x. So let's check the degree of freedom 1 and define the magnitude of load. So let's say it's 10. Now the load type, remember to change the load type to D area. So D area is the type of load which let you define the time dependent load. So make sure you keep that in mind, and let's create. Yeah, the software has defined it. Now we have defined constraint, we have defined loading. Now what we have to do is we have to define a table which will tell the software how the magnitude of load is changing with respect to time. So for that we'll be seeing a table. Now this is the table we were talking about. So what you can see here is 0, 1010. So 0 is the time and 1 is the load scale factor. Means whatever the load that we have just defined, that is 10, it is going to be multiplied by 1. And now and then as the time changes to 1000 seconds, means 0 1 2 3, it will go on iterate up to 1000. So on that basis our load factor will be changing from 1 to 10. So it is quite self-explanatory how this is changing. From time 0, the loading scale factor is 1, and at time 1000, at second 1000, the loading scale factor is 10, and the value in between the software is going to iterate by itself. We don't have to worry about it. So now that we have seen the table, let's define, let's assign uh, the software, let's assign this table to our analysis. Now let's assign that table to our component. So for that, go to utility browser and then table create and import table d1 as the type of table, and then click on next. Now select the file that you have created, text file, and name it as tab. Okay. So the software says the curve tab with table d1 card image is created. Now that we have loading, and now we have time versus load scale factor table. So what's the next step to do is we have to combine them. So how could you combine them? By using tload card image. So the load collector is tload, and card image, set the card image to tload. It will be on next page, tload1. You could use tload1 and then create it. So in the excite ID, select the time dependent loading, and in TID, that is table, select the table that we have just created and then return. So now our condition is all defined. Now what we have to assign is the damping factor value of G. So for that, go to control cards and go to next, select param card image, and scroll until you find G. So yeah, it's G here. uh, 0.2, give the value of damping factor as 0.2. So the damping is we define damping because the our structure won't be, it is going to absorb some shocks or some movement. So that is the reason we have defined damping. It is not going to resonate with the external cyclic frequency. It is going to absorb some. So that is the reason we have defined the damping factor. Let's define T-step. Now what is T-step? The T-step card image will tell the software how long our analysis is going to perform, for how many seconds. So for load collector, card image as T-step, T-step card image, and then created it. Define the initial condition as, say, how many numbers, 1000, and dt is 0.5. Let's set this as 0.5. Return. Now one last thing that you have to do is define global output respect, global output request, to request the displacement and stress. So for that, go to control cards and go to next, and then select global output request. Now request here the displacement, make sure it is format as h3d, and just scroll right and select the option for yes, set to all, already set to all. so that we get the analysis done for all the mesh. And also stress, same for stress, form as, no, not form, option, yes, set to all. Now return. So now at the end, let's define the load steps. Go to load step panel and select the type as transient direct. Make sure it is transient direct. Name it as tran and select SPC as SPC, deload as tload1, and T step as T steps. So these three conditions you have to define and then create. Return. And now we have just we need just to save the file and solve the file. Save and optistruct. So it is going to take some time. So the solver has done solving the part. Now let's look at the result. First we'll be looking at displacement. So as you can see, the value of displacement is 0 here because the time is set to 0. If we increase the time, the values will be increased correspondingly. So the way I like looking at it is setting up the animation. So for that you go to the set linear animation mode and start animation. So it will perform some iteration before presenting the animation. So this will give you a clear understanding. If you want to see the value of displacement at any particular time, then you can do it by whatever the time that you want by setting the time here, and at that time you will be getting the value of stress or displacement or corresponding values. Now let's see the element stresses. Averaging method is simple and apply. So it is performing some iteration before presenting the result. So yeah, the value of stress at the very edge is quite high because of having less cross section area there. So yeah, we are done with our transient response analysis. For more videos, you can bookmark the playlist if you want to see more. And yeah, thank you for watching.